On the left is an isolated text prompt box. On the right, an integrated system linking an API, a large language model, and an external database. Companies are no longer hiring people who only know how to type prompts into a chat window. They are looking for builders, engineers who can design and ship complete end-to-end AI systems. If you already come from a backend development background, you are starting with a massive advantage. You already understand system design, scalability, and how to debug complex applications. The skills you use every day transfer directly into building AI platforms. For your first month, the focus is entirely on the foundation. Python is the dominant language in this space, so you need to be comfortable with its syntax, package management, and object-oriented concepts. From there, you need to learn how to build backend services using frameworks like FastAPI. Let's look at this code schematic. A FastAPI request routes to an external OpenAI endpoint and then returns a structured JSON response. This is the core mechanic of AI engineering, sending data to an API, handling the response, and passing it back to your application. Within that JSON request, you have to format your data correctly. This requires mastering prompting techniques like zero-shot prompting, and specifically structured outputs. You need to enforce rules so the AI returns data exactly how your backend expects it. Until you can reliably build this API pipeline, nothing else works. You have to guarantee the model can communicate cleanly with your backend before you can trust it to handle external memory or make autonomous decisions. In month 2, we tackle the problem of external memory. Language models do not know anything about your private company documents. To fix this, we build a pipeline called Retrieval Augmented Generation, or RAG. This diagram shows the first phase. We take a standard PDF and mathematically prepare it. The document is systematically segmented into smaller, manageable text blocks called chunks. Those individual text chunks are then pushed through an embedding model. They are converted from readable words into long arrays of numbers. These number arrays are then plotted into a vector database. By storing the data spatially, the system can retrieve information based on context and relevance. When a user asks a question, the system retrieves the most relevant chunks from the database and injects them directly into the prompt context. This forces the AI to synthesize an answer based specifically on the provided text, rather than its broad training data, which significantly reduces the risk of hallucinations. The second half of month 2 shifts toward building autonomous agents. These systems use logic loops to determine which tools to use and when to use them to solve multi-step problems. Here is the core logic of an agent. It follows a continuous planning loop. The agent outputs a thought about what to do next, executes an action, processes the observation from that action, and decides its next step. To execute those actions, agents need tools. The Model Context Protocol, or MCP, is the standard for this. It connects your agent's loop directly into external enterprise software, allowing the AI to query databases, read Jira tickets, or send Slack messages. Before we move to the final month, hit pause. Take a piece of paper and try to draw the entire RAG memory pipeline and the MCP agent architecture from memory. Linking RAG's retrieval with MCP's connectivity allows the AI to fetch specific company data and use it to perform real-world tasks across different enterprise platforms. This turns the AI into a functional digital worker. Month 3 is about the reality of production. Having a local prototype running on your laptop proves you understand the concepts, but it holds zero value to a hiring manager until it is deployed, monitored, and stress-tested on real servers. Look at the right side of this deployment map. Traditional software either works or crashes, but AI is non-deterministic. You have to build evaluation systems to continuously track answer quality scoring, detect hallucinations, and manage strict token budgets to keep costs under control. The most common trap at this stage is superficial learning. Beginners try to memorize dozens of different orchestration frameworks and vector databases. Ignore the noise. Focus on mastering the deep end-to-end pipeline of a single stack. To get through this material in 3 months, use the 1-1-1 daily routine. Spend 1 hour learning new concepts, 1 hour building projects, and 1 hour improving your code quality or reading documentation. This 3-month roadmap leads to a specific portfolio. You need 4 things: a RAG chatbot that provides citations, a multi-tool agent, an MCP server exposing real enterprise tools, and a production-grade fast API backend deployed live. Certificates and theoretical knowledge are easy to acquire. Shipped projects are hard. They are the undeniable proof of your execution ability, and they are exactly what modern companies are paying for.
Thank you. Share and subscribe to Learn AI for more AI insights.